A smoldering disconnect for a heat pump can be a serious fire hazard. Several potential causes need to be investigated to prevent recurrence. Even if connections appear tight, they may not be making proper contact. This leads to arcing, which generates heat. Inspect each connection thoroughly, ensuring the wires are properly seated and the terminals are tightened to the correct torque specification. Use a torque screwdriver to verify the tightness of each connection. An oversized disconnect rated for a lower amperage than the load it's carrying will overheat. Verify the heat pump's nameplate amperage, including the minimum circuit ampacity and maximum overcurrent protection, and ensure the disconnect switch's amperage rating meets or exceeds these values. Also, the disconnect may have been manufactured improperly, or it may have defective components. Choose disconnects from reputable manufacturers and look for certifications from testing laboratories. Water ingress can cause corrosion and electrical shorts within the disconnect. Inspect the disconnect for signs of water damage and ensure that all seals are intact. Consider using a weatherproof disconnect enclosure if the disconnect is exposed to the elements. Inadequate grounding can allow stray currents to flow through the disconnect, causing it to overheat. Test the grounding conductor's continuity from the disconnect to the main electrical panel. The grounding electrode conductor should be properly sized and connected to a grounding electrode system. A malfunctioning circuit breaker may not trip when it should, allowing an overload to occur. Test the circuit breaker with a multimeter to ensure it trips at its rated amperage. Also, verify that the breaker is the correct size for the heat pump circuit. While no problems were initially found, an intermittent fault or subsequent issue with the heat pump could cause the disconnect to overheat. Monitor the heat pump's performance and look for signs of unusual behavior, such as excessive noise or vibration. Check the compressor's windings for shorts or ground faults. To prevent future incidents, several steps should be taken. Firstly, thoroughly inspect all electrical connections to ensure they are tight and secure. Secondly, confirm that the disconnect is rated for the correct amperage and voltage of the load it is serving. Thirdly, invest in a disconnect that is known for its reliability and safety. Fourthly, seal around the disconnect to prevent water from penetrating. Fifthly, verify that the disconnect is properly grounded in accordance with electrical codes. Sixthly, ensure that the circuit breaker feeding the disconnect is functioning correctly. Periodically inspect the disconnect and heat pump to identify any potential issues early on. This includes visually inspecting the disconnect for signs of overheating, corrosion, or damage and checking the heat pump's performance for any unusual behavior. Consult the National Electrical Code, specifically Article 440, for requirements related to air conditioning and refrigeration equipment. Also, consider the wire size. Conductors that are too small for the load will overheat. Verify that the wire size is appropriate for the heat pump's amperage and the length of the circuit, consulting NEC Table 310.16. Examine the type of wire insulation. Using the wrong type of insulation can lead to premature failure and overheating. Ensure the wire insulation is rated for the temperature and environmental conditions of the installation, consulting NEC Table 310.104a. Look at the ambient temperature. High ambient temperatures can reduce the ampacity of conductors and increase the risk of overheating. Consider dirting the conductors if the ambient temperature exceeds 30 degrees Celsius as per NEC Table 310.15. Consider the altitude. High altitudes can reduce the cooling capacity of electrical equipment and increase the risk of overheating. Dirt the equipment if it is installed at a high altitude following the manufacturer's recommendations. Also consider voltage imbalance. Voltage imbalance can cause excessive current flow in one or more phases of the heat pump motor, leading to overheating. Measure the voltage at each phase of the heat pump and ensure that the imbalance does not exceed 3%. You can also look at harmonic distortion. Harmonic distortion can cause overheating of electrical equipment and conductors. Measure the harmonic distortion in the electrical system and take steps to reduce it if it exceeds acceptable levels. Consider surge protection. Power surges can damage electrical equipment and increase the risk of overheating. Install surge protection devices to protect the heat pump and disconnect from power surges. Look at load calculations. An inaccurate load calculation can result in undersized electrical equipment and an increased risk of overheating. Ensure that the load calculation is accurate and includes all of the heat pump's electrical load. Inspect the location for proper ventilation. Poor ventilation can trap heat and increase the risk of overheating. Ensure that the disconnect and heat pump have adequate ventilation. There can be corrosive environments. Exposure to corrosive environments can damage electrical equipment and increase the risk of overheating. Protect the disconnect and heat pump from corrosive environments. Check for proper overcurrent protection. Overcurrent protection devices that are too large or too small can create a fire hazard. Ensure that the overcurrent protection devices are properly sized and coordinated to protect the heat pump and disconnect. Use proper installation practices. Improper installation practices can lead to a variety of electrical problems and increase the risk of overheating. Follow all applicable codes and standards when installing the disconnect and heat pump. Use thermal scanning. Thermal scanning can be used to identify hotspots in electrical equipment and conductors. Perform thermal scans of the disconnect and heat pump to identify any potential problems. Check for proper maintenance. Lack of maintenance can lead to a variety of electrical problems and increase the risk of overheating. Perform regular maintenance on the disconnect and heat pump to ensure that they are operating properly. Also, use qualified personnel. Electrical work should only be performed by qualified personnel. Ensure that all electrical work is performed by a licensed electrician. Also, keep accurate records. Keep accurate records of all electrical work, including inspections, maintenance, and repairs. This information can be used to track trends and identify potential problems. Look at the disconnect enclosure. Damaged or corroded disconnect enclosures can compromise safety. Replace any damaged or corroded enclosures. Check the terminal blocks. Loose or corroded terminal blocks can create a fire hazard. Tighten or replace any loose or corroded terminal blocks. Also, check for proper wire terminations. Improper wire terminations can create a fire hazard. Ensure that all wire terminations are properly made and secured. You should also consider arc fault circuit interrupters. Arc fault circuit interrupters can help to prevent electrical fires. Consider installing arc fault circuit interrupters on circuits that feed heat pumps. Also, consider ground fault circuit interrupters. Ground fault circuit interrupters can help to prevent electrical shock. Consider installing ground fault circuit interrupters on circuits that feed heat pumps. Another aspect is the equipment grounding conductor size. An improperly sized equipment grounding conductor can create a safety hazard. Ensure that the equipment grounding conductor is properly sized according to NEC Table 250.122. Also, check the grounding electrode system. A faulty grounding electrode system can create a safety hazard. Inspect the grounding electrode system to ensure that it is properly installed and maintained according to NEC Article 250. Use proper labeling. Proper labeling can help to prevent electrical accidents. Label all disconnects and electrical panels clearly. Also, consider load diversity. Overlooking load diversity can lead to overloaded circuits. Account for load diversity when calculating the electrical load for a heat pump. Check for voltage drop. Excessive voltage drop can cause equipment to overheat. Measure the voltage drop in the circuit and ensure that it is within acceptable limits. Consider the short circuit current rating. The disconnect must have a short circuit current rating sufficient for the available fault current at its location. Verify that the disconnect short circuit current rating is adequate. Also, you can check for proper coordination. Improper coordination of overcurrent protection devices can lead to nuisance tripping or failure to trip during a fault. Coordinate the overcurrent protection devices to ensure that they work together properly. Look at the power quality. Poor power quality can damage electrical equipment. Monitor the power quality and take steps to improve it if necessary. Consider energy efficiency. Energy-efficient heat pumps can reduce energy consumption and lower operating costs. consider installing an energy-efficient heat pump.